Let's do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. Find us on the web at gotime.fm, on the Fediverse at GoTime, at changelog.social, and on X at GoTimeFM. Thanks to our partners at Fly.io, the home of changelog.com. Launch your app as close to your users as possible. Find out how at Fly.io. Okay, here we go.
Well, hello, and welcome to this episode of Go Time. Today, we are going back, well, at least Ian and I, we're going back to what it felt like to be a new Go developer, because chances are we've probably forgotten that feeling. And we have a special guest coming on the show to talk about their experience of being a new gopher, and they actually suggested an episode, which you can do too, listener. You can suggest episodes, and who knows, maybe we'll even invite you on the show and come talk about the stuff you're proposing. But yeah, I propose that we, sort of answer, some questions that a new Go developer would have. And we thought, you know what? Why don't we bring him on the show and have him tell us what his experience has been and ask some questions. So we're treating this as sort of an office hours style episode, and hopefully we'll do more of those in the future. But yeah, this is we're very glad to have you on the show, Duarte Carmo. Hopefully I'm not butchering your name. Welcome to the show.
No, that's great.
Good to have you. And co-hosting with me, as you might infer from my previous comments, is Ian Lopshire. Hello, Ian. How are you?
I'm doing well.
Good. You ready to feel like a newbie again?
I mean, I just felt like a newbie like yesterday, making silly mistakes. So yeah, I think I'm prepared.
Okay. All right. So Duarte, why don't we start with a quick intro and give us a little bit of background, and we'll get into also how you got into Go.
Yeah, sure. So first of all, thanks a lot, guys, for having me. I think this is the most spoiled office hours that I've ever had in my life. So I'm honored. Yeah. So thanks a lot for having me, and really, really nice meeting you. So first of all, a quick and short background. My name is Duarte. It's a weird non-international name. I'm originally from Portugal, from Lisbon, but I've been based in Copenhagen, Denmark for the past 7, almost 8 years now. So that's like north of Europe, which is very different from Portugal, for those who don't know. And my background is a little bit of a mixed bag. I've worked a little bit like my background is master's in engineering. I did like strategy, product management. I did a lot of different things, and then got more and more technical over the years. And for the past, I also did some management consulting, things like that, and IT architecture and management and things like that. But in the past 3 years, my main goal is that I basically help companies solve tough problems. And that is normally related to more like the data science, software engineering side. But I like to think of myself as someone who can also put stuff in production, like if you guys are familiar with the concept of Jupyter notebooks, I like those, but that's not normally what I put into production. So yeah, so that's a little bit about my background.
Cool. And how did you stumble onto Go?
I have this thing where I'm very curious about like new programming languages and new programming paradigms. So my background, it's a lot like on the research machine learning side, but I'm very passionate about putting these things into production. So I got more and more passionate over the years to the software engineering side. And normally the tool that I use, I just go for Python. And until a couple of years ago, that was just a no-brainer for me. I just used Python, and wherever I could stick Python, including your browser, that's what I would normally go with, even if that's really inappropriate. And so in the past couple of years, I started hearing about these new programming languages. The first one of them was Rust. And I got into Rust, and I decided to do the Advent of Code. For those, I think most of us are familiar with Advent of Code. I tried doing Advent of Code in Rust. That went okay. Like, of course, I didn't make it past like day 16, which was fine. But I really, really enjoyed the experience. I felt like it was a very different software experience than I was used to with Python. And I also decided to build a website in Rust, something that would basically transcribe one of my favorite Portuguese podcasts, which is like political commentary. And what fascinated me about Rust is that the website never went down. Like, it never crashed. Like, it's nice. Still running. I've deployed it once. It transcribes all of the podcasts, and it has never gone down a single time. And I'm like, okay, like, I'm not that good of a programmer, so I'm sure there's like a component here that is based on the language. And so for the past couple of projects, I decided that Rust was really nice, but there must be a good in-between of being really strict about how I write code, right? So not like, of course, being hard for me to develop something, like the time to market to be a bit longer, but also to be not that long. And Go, I was hearing that it was a good language that also, in a way, you guys probably know better than me, sits good in the middle, where it's like you won't take as long as writing something in Rust to get something out there, but it will be probably not as fast as Python, but it will be much more robust and solid, quote unquote, than writing something in Python. Of course, what I say about these programming languages has a lot of caveats, right? Like you can be a great programmer and write something in JavaScript that is much more robust than something in Rust, but I think the languages kind of guide you. And so for the past couple of like side projects, I've been going with Go, and that's how I came about it, basically. That's how I thought about using it.
Okay. Well, let me just start by saying that, getting 16 days into Advent code is no small feat. So, definitely, don't sell yourself short there. So, a lot of people I know, they'll be like all gung ho and excited. And then, like day 5, it's like, I give up.
Right. Especially in holiday season.
Exactly. Especially during the holidays. Yeah. It's as much, to me, that has always been as much of a lesson in time management, right, as it is about sort of getting through all the exercises. But awesome. Well, it's glad to have you in the Go community. Welcome on behalf of the Go community, if I may. Definitely, we enjoy having one new developer in the community. It's interesting sort of hearing you sort of describe what led you to try Go, right? So, all of us, we hear about different programming languages all the time, and we don't always necessarily sort of run towards them or gravitate towards them for one reason or another. The fact that you came to Go looking for something perhaps not as, I guess, if you consider, a spectrum where you have Python, where you can develop quickly and get something out the door quickly because it's what you know and have been using for a long time, and then having Rust on the other end of that, right, which is has all these sort of wonderful ways of ensuring that the stuff you have in memory is the stuff you actually want to have in memory, right, where you have to be very strict about what you're doing and know what you're doing, right. Go kind of gives you that sweet spot in between, right, where you can get good performance, where you can get something out the door, and if you follow all the idioms, right, of the language, you will get something that looks like production grade Go code, without having to sort of be a master of the language, right? So I think
this is why we're having this conversation, because the idioms is completely unknown to me. It's like oh yeah, but if you follow the idioms, then I'm like, yeah, I'm pretty sure I have not followed one of those.
and that's okay. That's okay. That's why we're gonna get into it shortly here.
What you're about to hear are real reactions from PagerDuty users in response to seeing signals from Fire Hydrant for the first time.
PagerDuty, I don't want to say they're evil, but they're an evil that we've had to maintain. I know all of our engineering teams, as well as myself, are interested in getting this moving the correct direction. As right now, just managing and maintaining our user seats has become problematic.
That's really good, actually. This is a consistent problem for us and teams, is that covering these sorts of ad hoc time frames is very difficult. Putting in like overrides and specific days and different new shifts is quite onerous.
Oh, and you did the most important piece, which is didn't tie them together, because that's half the problem with PagerDuty, right? Is I get all these alerts, and then I get an incident per alert. And generally speaking, when shit goes sideways, you get lots of alerts because lots of things are broken, but you only have one incident.
Yeah, I'm super impressed with that, because being able to assign to different teams is an issue for us, because like the one alert fires for one team, and then it seems like to have to bounce around, and it never does. Which then means that we have tons of communication issues because like people aren't updated.
No, I mean, to be open and honest, when can we switch?
So you're probably tired of alerting tools that feel more like a headache than a solution, right? Well, Signals from Fire Hydrant is the alerting and on-call tool designed for humans, not systems. Signals puts teams at the center, giving you the ultimate control over rules, policies, and schedules. No need to configure your services or do wonky workarounds. Ingest data seamlessly from any source using webhooks, and watch as Signals filters out the noise, alerting you only on what matters. manage tasks like coverage requests and on-call notifications effortlessly within Slack. You can even acknowledge alerts right there. But here's the game changer. Signals natively integrates with Fire Hydrant's full incident management suite. So as soon as you're alerted, you can seamlessly kick off and manage your entire incident inside a single platform. Learn more or switch today at firehydrant.com/signals. Again, firehydrant.com/signals.
Let's start with, I think one of the things you listed in some of the questions that you had was the idea of dealing with a binary. You like the idea of a binary. So what are you sort of juxtaposing that to?
Yeah, like that's something perhaps I should add also, John, is because, of course, I think about Go as something that sits nicely between something like Rust and something like Python. But I also really always loved the idea to have like a binary. So Rust always gave me that really feeling of like, okay, I can just give you something. And for those of you that for some of you that have programmed Python for a lot of years, know how frustrating it is that all you have is a script. Mm-hmm. all you want is to give that script to someone so that they run it. Yeah, but that never happens. And so I really enjoy the side of the spectrum of things where we can actually just have a binary and make things run. I think that's really, really nice. And I also always heard these things about Go being a very simple language in a way that two people with varying levels of experience might write a piece of code that is much more similar in Go, so that it's kind of a simple language. It's not plain, but in a way that it makes things obvious and it guides you to do the right thing. And that's also like something that appealed a lot to me, because one of the things that I hate is making things complicated when they don't have to be. And so yeah, like that's just a couple of things that I really enjoy about Go. And also like my way of learning these things is that I have some itch that I want to scratch and I write it in Go. That's kind of how I go about it.
You're kind of discovering, like sort of naturally, right, organically, the sort of the virtues of the language. You know, the literally like part of the language's sort of aims. One of it was to literally allow for somebody who is new to Go or a junior developer or somebody who is perhaps experienced but still new to the language to basically write Go code that looks almost as good as a pro Go developer. It's the first language that I've personally come across that sort of really guides you towards that, right? Like, you know, I've been amazed to see new Go code being created by new Go developers that is not too far off from what I would expect from an experienced Go developer, right? And I think that's by design. Like the language kind of guides you, right? It kind of puts you on this path, puts some guardrails around you, and your code ends up looking, right, very much like, you know, what a professional would write.
We haven't seen my code, John.
Well, let's start peeling back some layers.
Yeah, I think you'll have a couple of heart attacks. But sure. Yeah.
I know. Maybe we should also bring you back to do our roast, our project roast. We've been thinking about a kind of episode where we roast projects. So maybe we'll bring you back for those.
I mean, but you said something that is really, really important that I always feel like is that whenever I read Python, in like the professional context, I feel like I see these dialects of Python where two different like Python programmers will write Python, or two different projects Python will look completely different. For example, now everyone likes types. So if you catch a developer that loves types, then you'll see type Python, which is very different from normal Python. So there's kind of different lingos, and I feel like that doesn't happen so much in Rust, right?
In Go.
Yeah, in Go. Sorry, yeah, in Go. Sorry.
Oh, yeah, that's the thing. When you're playing around with lots of languages, sometimes you end up sort of.
I haven't gone into the functional spectrum yet, but yeah.
Oh, that's a worthwhile endeavor as well. But yeah, like you have a list of questions here, and I think I'll let you guide the conversation as to kind of what do you want to tackle first.
Okay, so the first thing, some context. I was writing a couple of projects. The first one was that I wanted to basically build my personal LLM, and I wanted to basically access the Telegram API, and I want something that calls APIs and then calls the Telegram API, and it's like a personal chatbot if you want it. But it just needs to be a microservice that calls APIs. That's all it needs to do. It doesn't need to do much more than that. And so when I started writing this project, the first thing that I noticed is that, and even when I was looking at code, is that there's this for every 4 lines, 2 lines are if error equals nil, then do something. And I'm like, okay, great. This might be like something specific to this project. Then I go to another project. Like I've actually worked with a company that had a Go code base and I dwelled in it. And it also had this pattern. And I'm like, I'm basically seeing this if error equals nil everywhere in my code, and I don't know what to do with it. So is this normal, Johnny? Tell me.
Well, Ian, why don't you get us started? Because I have thoughts and opinions.
I think not only is it normal, and it can be jarring at first, because like you said, it does occupy a lot of space, but it's also kind of my favorite part. So it's hard to not like it. I don't know. But yes, it's completely normal and expected, and at least the if error equals nil part, what you do after that kind of changes. But yeah, I think you're always going to see that. There's been so many proposals to try to change that, and all of them have gotten shot down, and I like that they have all gotten shot down.
I feel like it's the personality of the Golang programming language thing for now.
Yes, but not because the creators of the language wanted to be anti, right? It was I think I can't remember the name of the paper, but there was a paper once upon a time that I read, and then I immediately sort of understood why the creators of the language sort of chose to go that route. The paper talked about sort of explicit handling of error values, right, as opposed to sort of some languages where you're going to see some exception handling, right? So you can see a try, a catch, finally, or something like that, right? And then basically just bubbling up the error all the way up the stack, right? And hopefully something will catch it and handle it and do something with it, right? So the Go doesn't have exception handling, right? Go has error handling, and the error values, right, need to be treated sort of and handled sort of right then and there when they happen, right? There's no the traditional approach of the try, catch, and finally, and sort of that style, right, of handling exceptions is not present, right? So when you see the typical sort of multi-value return where the last values type, right, is satisfies the error interface, right? That's the idiom, right, within the Go community. Basically indicates that, okay, you're going to make some sort of function call, and if something goes wrong, if there's a possibility of something going wrong within that function call, expect that, if you say, you're returning 2 values, right, maybe the first value is what you really want, should everything go well, and then the second one, right, is something that satisfies the error interface, you should check to see if something went wrong, right, and decide what you're going to do rather than there. Maybe in some cases, maybe you want to call a different function, and maybe you want to retry, right? Maybe you want to log something out or capture some sort of metrics. Maybe you've got some open telemetry tracing in there. Maybe you want to send a trace somewhere. However you want to handle that error, right? Sort of the idiom is to sort of handle your error right then and there, as opposed to sort of allowing it to bubble up the stack and hopefully something handles it.
And so is this the concept of if you're like deep into the code base, you're like 4 functions in, and you have one large function that has perhaps 4 calls other 4 functions, and all of them have the value and the error. Is it something that you normally just return that error on that function and return back, or is something where you normally don't return back that error? So like my question is kind of, do you actually raise a panic anytime, or are you always returning that error back up the stack?
Well, careful with the nomenclature. We definitely don't want to. There's no raising of anything in Go.
Right,
and
exactly.
But
panic.
Even then, panic, right, means something very specific for us. So
right.
You don't want to sort of use that word sort of when you mean an error, right? So to use your example, depending on how you want to handle your error, right? You could simply, call a function. Maybe you're on a third of 4 functions, right? Maybe the third one calls a fourth. And if something goes wrong in the fourth and an error gets returned, and in third function, you could decide to handle the error right then and there. Maybe you try calling again. Maybe you do some other thing. Maybe if you want to log it out, maybe you log it out and then call it a day. Or more than likely, you'd probably return that error back to whatever called this particular function, right? What you typically want to avoid is sort of, maybe you have 4 functions deep, and all they do is they all log out something, right? So in your log, files, you end up having the same sort of error, or a similar errors, right, or similar root cause, right? Sort of all over your logs with no additional value, right? Yeah, you could do it that way. You can have each function log something out just so you can see, well, which function sort of aired out and made notice of it. But typically, right, you just want to allow, maybe it's your top level function, right, that it basically does the logging out or the tracing or whatever it is. Personally, the way I approach it, right, and maybe Ian has a different approach. Personally, the way I approach it is deeply nested function calls, right? I don't log anything out. I basically, within my context that I'm passing down to each of those functions, I'm doing open telemetry tracing. So I'm literally tracing, right, each function call. And then I'm not logging anything out. If there's an error to be recorded, I can add that to the span that I'm tracing, that I'm adding to my trace. And then I allow basically the caller, right, to do something with the error if they want to do something other than just, make a note of it in a trace somewhere, right? And then I'll allow it to my top level. Usually it's my main function somewhere or the main handler of some kind. I allow it to decide, okay, do I want to, I know I've already done some tracing. Do I want to then send this particular error to an external bug tracker, right? Or do I want to simply log it out if I want, right? But I'm localizing sort of beyond just the traces. I'm localizing the logging of that error to just into one place, right? Or communicating that error to an external bug tracker to just one place, right? But that's because I know I have tracing throughout the application, so I can rely on the trace to provide me sort of the breadcrumbs without having to rely on my deeply nested functions to be emitting log, because that's effectively what you're doing. You're trying to say, hey, this function was running when this error occurred, and you can go in your logs and kind of see what was going on, but traces give you the same benefit without you having to sort of pepper your log file with the same kind of error. Ian, do you have a different approach?
I would agree with everything you said. I guess my main philosophy is either handle it or add context and pass it up, right? So you'll see a lot of like format.arf with a W for wrap, and then they'll say like, hey, there's an issue with this user, or right. So you can add context all the way up. So even if you don't have tracing, a lot of the time you can see exactly the path that error took all the way back up to where it's finally logged out or handled. Or
okay, I didn't know you could add stuff on top of errors that already exist. So you could basically add something. How do you do that exactly?
There's quite a few ways, but one of the more common ones you'll see is like it's literally just like a format string where you pass the error as one place, and then you can add whatever content you want.
Okay. That's what I was doing. Okay, all right. So you basically create an error. Yeah.
You also have to understand, like an error, I mentioned the term interface earlier on very deliberately, right? So you can create your own custom errors. It doesn't just have to be like a string, value that you're just bubbling up. You can have contextual, sort of a composite that it represents, as long as it satisfies the error interface, meaning that it has a method on there called error that returns a string, and that's all it needs, right? So you can create a custom, a struct, right, that basically has fields that provide context. Maybe you might have a custom error that tracks a particular endpoint value or a particular number of retries or whatever it is, right? That way, when you're passing this error value right back to the caller, you can provide additional context with beyond just doing an FMT error F and just embedding the existing error. You can use a customized error value that provides a way more context than the simple error value.
Yeah, I think that's kind of the same concept we have in other languages, right? Where you can kind of like raise different types of errors, and you can have different and compose your own type of errors. Of course, Johnny, when you say interface, my brain sometimes still says class, but sure, it does make sense. I think for me, it's also the component of like, it looks like it's, if not done right, perhaps, right, Johnny? If you're not doing actually something with those errors, it looks so repetitive to have those if error equals null, then return null, whatever. That is just like, okay, what is the point of this? But
what is it exactly?
Perhaps the point is that if you do it actually correctly and handle those errors, then it actually looks like something, not just empty if error nulls, then return null, right?
Exactly.
Yeah, exactly. Okay, that makes sense to me. Should we go on to the second one?
Yes.
All right, so I mentioned that one of the things that I really like about Go, maybe last one, I have to ask this. So if you do the if error equals null, do you do the if error in this line after or in line? Because I've seen two variations where you do a statement, dot comma, you know what I mean?
Mm-hmm. Yeah. It's all about the scope, right? So if I'm returning two values, right? If I'm trying to sort of limit the scope of those two values, right, to just my if block, right?
Okay.
Basically, I can do if, like some variable, right, for the value that I'm trying to capture, comma, error, and then, my colon equal, and then I call my function, right?
Yeah.
And then I can, within that same if block, I can then say if error, not nil, then do something with the variable that I captured, right? So it's all about sort of the scoping, right? If you want to, basically whatever value that gets returned, if you want that to be available outside of the context of your if, then you pre-declare your variable. And then you can call the function, and then basically you're gonna get back. You can pre-declare your error variable. You can pre-declare your whatever value you want to capture, and then what gets returned from the call, those things will get assigned, right, to those pre-declared variables. And then you can do the if error nil check on its own line. But then what you can do, if you detect an error, you can return early. And then if you decide to basically, if the error check passes and there's no error, then you now have that variable that you pre-declared, and now it's not available to the rest of your whatever scope you're in, right? So to me, it's all about the scoping of the return values.
That makes a lot of sense. Okay. Thanks for clarifying.
My general heuristic there is like, do it in one line if you can, right?
Okay, there we go.
You can get away with it.
Yeah, if you can get away with it, do it. If not,
all right, there we go. Okay, perfect, awesome. Okay, so enough about errors. Let me ask about the second thing. So one of the reasons I mentioned that I really liked Go is that the fact that I had a binary, and that unlocked a full world of possibilities. But whenever I wanted to actually deploy the project, I was looking at some examples, and everyone was Dockerizing these Go projects, and is even the official Docker images for Go. And I've also actually seen this with similar type languages like Rust, for example, where we're still Dockerizing everything. So for me, it's like, what is the final advantage of having a binary? Is it that we can do like multi-stage builds that are smaller, or are we actually leveraging the fact that we have a binary?
I mean, the multi-stage build with tiny images is really nice. Just to be clear. But we actually don't Dockerize our production stuff. We run it on bare metal, and it's super easy to ship a binary from like GitHub Actions straight to bare metal, and it's still great. So I think it just more depends on your tooling versus.
So there's the tooling, right? There's the developer side of things. When you were talking about that, my mind quickly went to sort of the operational side of things. There are some advantages you're going to have when you create an image, right, of your executable for certain deployment environments. So if you wanted to sort of have orchestration tooling, right, the Kubernetes of the world, the Amazon sort of ECSs, the Fargates, and all these services, these are sort of container orchestration technologies. And you can manage sort of availability and having multiple instances running, and you can manage resources allocated to those programs. You can handle the networking between components. There's a lot of benefits to Dockerizing, right? To having images that can be deployed when you're using container orchestration tooling. In the case of Ian, perhaps they don't have those requirements, right? So they can deploy the binary directly. And I'm curious to hear how you manage your updates, Ian. Maybe use like a package manager or something for the particular OS. That's what I would probably think to do. But it's all, to me, it's all about sort of the operational sort of context for your program, and whether Dockerizing, making images of your program, makes it easier to scale up or down and things of that nature.
Yeah, I mean, if I think we were curious in how you actually manage those binaries in the machines.
Yeah, so I mean, we use Elastic Beanstalk through Amazon, which is just dead simple and easy. So that's why we use it. And it can still do all the auto scaling stuff and all of that.
They just abstract that from you, right?
Exactly. It's fully managed. Exactly. And yeah, for our small team, it works very well. Would recommend. A little bit weird, but we really haven't seen the need for like the big container orchestration type stuff.
Yeah, and also I guess when Johnny, you were saying that like if you have a standard in a very large team and everyone's on Docker, or if you're using like a Kubernetes or an ECR or something that has auto scaling and you want to define the number of containers, it's really easy if everyone's up to the standard. But what he is saying is that if we're just one team and we don't have that tooling in place yet, and we're not using like a Kubernetes or any like specific orchestration or container orchestration tool, then it's just easy to go for the binary. And I can also see that perhaps when you're shipping all of these CLIs in Go, the fact that you actually can ship a binary is really, really nice, right? Because if you're packaging it for others, then comes this whole other side that we're not talking about of like actually shipping dev tools And in that sense, like it's great to have a binary, I guess.
Yeah, when you were talking earlier about how do you share a Python script, my mind was immediately, went to like I have some battle scars from trying to share Ruby scripts back in the day with teammates and whatnot, variations on which version they had, or little quirks in how their gem package management was configured, and weird issues, right? That it just made it impractical to try and share tools, right, between each other. And then you try to basically solve the people problem aspect, right, and communicate, hey, this is the version of the things that we're using. You have to be on Ruby this. You can't be using non-standard VM there. You have to end up basically creating all these sort of rules around sort of trying to standardize so that everybody's on the same thing. But it's way easier to just say, hey, my coworker here uses Windows. Let me just create a binary, right? Let me just create an exe for them, right? Just build an exe for them, right? Oh, my friend over there uses this particular flavor of Linux. Okay, let me build something for you, right? I'm on Darwin, I'm on a Mac, right? Let me build something for me and my other Mac using teammates, right? And the build process in Go is, I can't tell you how amazing it is, right? Just by specifying a couple of environment variables, just specifying what operating system and what CPU architecture am I building for, it takes care of the rest. It's magical, right? Now, something like that is incredible, right? If you come from build farms, if you have any experience with build farms or anything like that, you will love the experience for building different binaries, different executables for different platforms. That's one of the strengths of Go.
I mean, for me, that was also obvious when you mentioned it, Johnny, like the building, but also like the tooling around the Go programming language, also in terms of like the packaging of like, I always think that in Python, and I've been working in Python for some years, and we still feel like we're reinventing packaging every 6 months. It's just like the new, JavaScript, JavaScript frameworks. It's like the new framework, the new Python like dependency management solution that will take care of all the problems. We have those every 3 to 6 months, but in Go, it feels like you have a great package managing solution. And it also comes to kind of my next question, which is related to packages. And I was really surprised when I started working at everything in some of these Go parts. Everything seems so simple and so flexible, but there's still something that I quite don't understand, is that I was basically creating multiple packages inside of my repository, in my Go kind of app. It had multiple packages almost, and each of them kind of referenced the name of my GitHub repo. It was almost like github.com/my GitHub username / whatever that package was. And it felt like it's a little bit of like Far West where I could do whatever I wanted. But I think this is kind of the opportunity to ask, how do you guys see this relationship between packaging and how's, like, I think there's some like namespace concepts also involved here, but I would love to get some of your thoughts of how does this work? Like, why does my package have the same name as my GitHub repo?
I don't even know where to start with that.
Oh no.
I mean, I think the main thing was when Go came out, it didn't have a package manager, right? You had a single Go path and you had to put everything in that Go path.
Everything in there.
Or it couldn't find it, right? So there's the necessity to namespace, and then the convenience of being like, oh, this is just, the name is where it exists. So as I download code, it's all in the right place. I guess I don't know beyond that if there's some history there.
We're not gonna drag Duarte through our interesting package management history in the Go community. It's safe to say that the module system that we have now, it's not everyone's favorite, but just like Go font, everybody pretty much loves it at this point, only because of the standardized nature of it. Well, maybe love is a strong word, but it's good enough. It's good enough. And it gives you sort of a reproducibility and a lot of other benefits. But to your question, having a github.com base domain name with your, GitHub handle, and it's not just GitHub, right? It's GitLab, it's Bitbucket, it's wherever, right? Whatever your code repository tool of choice is. Basically, it makes it easy for the go get command, right, to know exactly where do I go and grab this particular package, to pull it down and store it in a local module cache, right? That way, I don't have to keep pulling it down every time I do a build. Basically, it just makes it, and then when you are looking at code, literally just copy and paste this package path, right, into your browser and to the repo you go, right? So it makes it easy. There's so many benefits to having the path, right? It provides a namespacing. There's not gonna be any conflicts as to, naming conflicts. Maybe you have two packages named foo, right? If one's under a particular github.com/username/foo, that's going to be very different, right? Just by looking at it, it's going to be unique, right? Because there's no two packages that are going to have the same naming, right? And you don't have to jump through hoops to do any funky aliasing or anything like that to know which one you're dealing with, right? So there's a lot of benefits to doing it that way. And one of the things I try to teach developers is from the get-go, right? When you first install Go, if the install doesn't create it for you, but you should create it yourself, there's going to be a Go directory that gets created under your root username sort of account, right? So if you're on a Linux machine or something like that, right, under your home, right, there's going to be a Go folder that gets created. And this is where I typically tell folks, like, look, when you download any package that you do a Go get, right, there's going to be a PKG folder that gets created under this Go directory for you. And this is where the module cache lives. This is where anything that you download that you don't vendor, and we can talk about vendoring if you'd like, but anything you don't vendor is going to go into that particular module cache. And then, from there, you can create an SRC directory where you put your code. So I, create an SRC directory. I have a github.com subdirectory followed by my jborsico GitHub handle. So I have the hierarchy that allows me to basically say, okay, anytime I'm looking for code, right, or anytime I need to check out code or fork a repository or whatever it is, I need to bring it locally, I just go into my Go SRC github.com / whatever username / project name. So it simplifies everything. I know exactly where to go look for the particular source code for a project that I'm working with directly. And I know exactly where to go in a module cache to find the module code I'm looking for. And even when I vendor my dependencies in a particular project, in my vendor directory, there's a hierarchy in there. There's a github.com followed by a username, followed by whatever project that I'm relying on as a dependency. So it just keeps that consistency across the board, right? And when I I can use multiple versions of the same dependency, right? Because the module system follows a semantic versioning mechanism. So, I know it might feel a little odd, it might feel a little weird at first, but trust me, we in the community have been burned. Not burned, but we've gone through some hardships, right? And we understand the value of what we have now. It's not perfect, obviously nothing is, but it works well enough that it creates that predictability and that reproducibility for our builds.
I had seen it once before. Where? In Vim, actually. So whenever I install a plugin, the reference is always someone's GitHub repo. So whatever packages you install, it always goes back to the GitHub repo. But what you mentioned about consistency for me is really, really clear, especially in a Go project where I actually know where everything comes from just by you being able freely to put whatever you want wherever in a way of like whatever packages you want to put inside of your GitHub repo, you're sort of free to do so. And that's the problem that I saw in Python, where I'm very constrained sometimes to have to put some things in certain places and in their certain structure. And I felt this freedom and simplicity that I think is really characteristic of Go, that, if you want to just create another folder and make a package out of it, great, do it, no problem. And that was really, really cool, actually.
Good. Glad you like it.
Yeah, I do think how we do the package naming really just fits well with like the Go ethos of just like stupid simple.
Keep it simple. Yeah.
Like I can't think of a simpler way to do it than just where it exists.
Yeah, that's a really good point.
What else you got?
Okay, so we talked about the packaging and how that connects to GitHub repos. And I also wanted to talk about structure. And to give an example, I'm going to give an example of something. One of these side projects that I built was basically a website that we can read news from Denmark, but in English. And it's basically I guess like a very simple web app. And I started thinking, okay, I have these types that I'm starting to writing more types. I have something related to like the parsing of websites or RSS fetching. And then I have something related to maybe, like serving the web page or templating or whatever. And I wanted to ask, is there a way that you normally structure these things? Do you structure your Go? Is there like, I know probably there are 5 answers to this, but there's no consensus. So maybe give you a personal opinion.
I'm excited for Johnny's answer on this one. I still struggle with this. I've still made mistakes that haunt me. Like, a new thing I wrote last year is I'm like, oh, that's wrong. Like I would not do that again. So yeah, I'm also interested for your.
So it's just like Python, is what you're saying.
Well, I mean, I wouldn't go that far. Here's like you, I've come across many different approaches, right? And I think we've had attempts, right, in the Go community at sort of specifying sort of standard structure and for Go projects, et cetera, et cetera. And even the Go team themselves, right, have sort of shied away from saying this is how you should structure your projects, right? It's at first I thought it was not great that there was no standard approach, and then the more I use Go, the more I realize, okay, I have flexibility, right? I'd rather idioms, right? If you've ever heard sort of a what's the term, convention over configuration, from my time in the Ruby and Rails world, that's like a mantra, and I think we've carried that into. Or I carry that sort of a mentality into my Go projects. But I will say that at a very minimum, once I know what kind of project I'm building, right, I follow a couple of different patterns. If I'm building an executable, ultimately the project may produce executables, but also itself be a package, right? The first thing I do the moment I create my repository, I'm going to create a CMD folder. Inside of that CMD folder, I'm going to have another folder representing the name or names of whatever executables I intend to build, right? So if I want to build 2 executables, one named foo, one named bar, in my CMD folder, I have a foo folder, and then I also have a bar folder, right? And in those folders, I have a main.go for each, right? So now I know this project, the moment I go into any repository, right? If I see a CMD folder at the root of that project, I know this project is at least is going to build, right, one or more executables. Right, that project itself may also, naturally will be a module in and of itself, right? And I know that there's going to be, the Go files that are at the root of the project, right, are going to have a package declaration. And I know if this project can be imported in some way, somebody can do a go get, github.com/username/ whatever project is. So that means even if that project has some executables in there, as long as there are things that can be used at the package level, right, for as a library, right, within a project, somebody can still go get that repository, but they can also do a go install to point to the executables, right, in the CMD folders, right? So you notice that that's the only sort of set of folders that I start with. I don't try to create a bunch of hierarchies. I don't have model folders. I don't have, a types folder.
Types folders.
Yeah, not that you can't have those, right? These things I find myself 9 out of 10 times, I find myself starting to introduce that sort of hierarchy and that sort of division once the project is mature enough for me to know that, okay,
once you need it.
Once I need it, exactly. I don't prematurely start to create a structure. This is not like a framework where you initialize a framework, you say create this project, and it spits out a bunch of different folders and files and everything else. I'm not using a framework, right? So I create these hierarchies when I need them, and I go out of my way to not create unnecessary hierarchy, because the more folders I create, the more packages, and I'm going to use the term sub-package, but there's no such thing in Go. There's only packages. The more of those nested packages I create, the higher the likelihood that I might have some sort of cyclical like import, kind of going on there, right? If I need to have one package use something from another package, like it creates all this sort of extra stuff that I have to keep in my mind now, right? Now, at most, if I'm building a server, a web server, for example, I might have a handlers folder at the top level where I can keep my handlers in there. That way I know where all my handlers are, and my handlers are probably going to share some code between each other, right? But that's going to be relegated to the handlers package only, right? And then everything else at the root has to do with, think of it as sort of core business logic behavior, right? That exists at the root of my project. And then I have a CMD folder with those executable folders in there, right? That is 80% of all the projects. That structure, that approach to simplicity for those projects, that's what they are. Again, the bigger the project, you don't want to go into a Go repository and you're just scrolling down for days because all the files are all in one at the root of the project. I mean, maybe that's suitable, right? If that's truly the case, if everything exists at the top level package. But, you don't want to sort of necessarily from the get-go try to create all these hierarchies and folders and inside of folders, because that's just going to create more of a mess for you.
Checking my web app repository. No handlers folder. All right. Okay. But there is a CMD folder.
Good.
There is a CMD, but with but just to clarify, Johnny, I'm just curious. When you mean folders, These are also packages in Go, right?
So think of it this way. The folder hierarchy is more so for you and I to communicate as developers than it is truly for Go. Because at the end of the day, the Go tooling grabs all of your files, right? And the only thing it cares about is the package declaration at the top of each file. That's the only thing it cares about.
So it just gets out of the way. It's what's beautiful about it. What I fell in love with Go is that what you said applies to any language and any software pattern that exists. It's like, okay, don't build unnecessary complexity when you don't need it. I'll handle a structure when I need it. But the fact that Go just gets out of the way when I just need to build folders is pretty nice.
Yeah, indeed.
And I should also caveat that the reason why I asked it was like Matt Ryer's How I Write HTTP Services in Go is like the thing that also inspired me to like, okay, there should be a good way of doing this. Ended up trying to implement some of the patterns, but ended up doing whatever I wanted.
I don't think this will ever be like a solved problem, because I do think Go like forces you to actually think about how your architecture and your package is. And you're just going to have to figure it out for every project in a way that kind of isn't fun, but I think it makes it better at the end, assuming you don't really mess it up.
You form some scars over the years.
Oh yeah.
You remember that you shouldn't create all of those unnecessary boilerplates because you're not going to need it in the future. Yeah. I think it's horizontal to most software projects. Okay, what about and you tell me when to stop, Johnny. I could stay here forever. But I was talking about, because I was developing this web application, and there comes a time where I eventually need to handle some data and store some data. And that's where normally tears start coming to my face. And I started having the realization that I'm going to have to be handling things like databases, which just add complexity that I do not like to deal with in general. And so I know that Go is kind of this stupid, simple approach. And you mentioned it, Ian. It's like, it gets out of the way and it's simple and it's obvious in most things. And I felt when I was like, okay, I'm going to start using some data. I'm going to do some, I don't know, insert statements in a SQLite database, whatever. Should I use an ORM? And I see a lot of these Go examples where they're not actually using an ORM. They're just writing the SQL code themselves. And of course, it's something else you can also do in Python. But I asked myself, is the Go simplicity going until the point where most Go projects don't use an ORM? Or like you should normally use an ORM?
This one's hard for me, because I see the benefits of the ORM. The main monolith I work on uses an ORM extensively, and I hate it. But
poor ORM. I feel like any ORM you would hate it.
I will say it's like, as far as like developer velocity goes, for 90% of the time, it's way faster, right? But I still don't know if that 10% edge case makes up for it when you're digging through Gorm code, trying to figure out why I'm inserting rows twice, like that sort of thing. I don't know. I can't think of a good example, but yeah, that 10% edge case is the worst part, and I don't know if it makes it worth it. I don't know. That was a rambling answer, Johnny.
I can add my 2 cents. The ORMs and frameworks and all these things, right? That class of developer tools, it's all about sort of velocity, right? It's all about how quickly can we move to get this out the door, and we don't have to reinvent patterns for data access and everything else. ORM sort of helps alleviate that. If everybody knows, to use Ian's example, if everybody on the team knows Gorm, then we know, what the Gorm code looks like, and we can intuit basically just by looking at a line of code exactly what data we're looking for, what the where conditions are, and and et cetera, right? It's easy because everybody knows what the API looks like. That said, in most cases, if you're just doing some CRUD work, it's perfectly fine. It's fine. Everybody knows how to use it. We can get moving quickly. Nobody has to spend time coming up with yet another way of doing the data access. In some cases where you need to tight control over performance or the kind of how you want your query to run, exactly what you want to join on, all these kinds of things. In the case of relational databases, you have the ability, right, to execute raw SQL statements, right, using these ORMs. I think most of them, if not all, have the ability to just, run an exec if you don't want any output back, or run on some sort of API call you can make to execute the raw SQL string that you're going to provide, right? So you have the sort of the benefit of both approaches, right, with these ORMs. And if you really want to, and if you want to execute your own query against the sort of raw database connection, well, you can just basically say, hey, give me the actual SQL connection, and I'm going to execute my my own stuff against there. If you want to see, okay, is it the ORM adding, extra stuff, or is it just the SQL that we're sending that's, maybe taking too long to return, or whatever the case may be, right? So ORMs are good for that particular use case. And the ORMs will tend to sort of, dynamically sort of based on the types you declare, based on the structs you declare and struct tags that you add to fields and whatnot, they'll try to do the best they can to infer a lot of things for you and manage, creating tables for you if you want them to, do migrations and all kinds of crazy things. But if in a case where you don't want an ORM to actively be in the path of every query you make, or trying to infer, columns and things based on the types that you have based on the fields that you have in structs, you can actually pre-generate things ahead of time, right? You can sort of you can use I think we mentioned Gorm as sort of on one end of the extreme, but on the other end in the extreme, you have things like SQL C or even SQL X, right, as packages within the Go community that have been used extensively, and a lot of folks have preference for those as opposed to using an ORM. So these things are more lightweight approaches, right, to doing database access over a full-blown ORM, which might have a little bit more bloat than you care for. So again, as with all things, it depends, right? But I think I've found in my project, I found a happy medium between using ORMs to move fast and then basically dropping down to writing raw SQL. Oh, by the way, you should always learn SQL. That's a skill that you'll never go regret, regardless of language or framework or whatever, 10 years from now, whatever, you're not going to regret learning SQL. So learn SQL. So when I need to actually drop down to actually writing my own very SQL, like especially trying to get things like window functions through an ORM, very incredibly hard, right? I just drop down to raw SQL whenever I need to do things of that nature.
As a machine learning engineer, I've learned that through the software developers' need or tendency to use ORMs. Normally, who's writing the SQL? It's more on this side because we need to access the actual data. So I completely feel you. But I also feel like it's perhaps I had this thought that it was a very Go specific thing where Golang or the Go community tends to jump less towards an ORM than most other communities. That's what my feeling was. But I think also, like you mentioned, Johnny, if like complexity increases, right, and you want that the velocity and you're working like at the bigger scale, then you're probably going to want to use, especially like for the migration use case, I guess, the ORM.
Yeah, some ORMs will come with that built in. I also know of especially dedicated projects that do migration. That's all they do, right? So again, it depends on your use case, but try different things and don't commit too early to any one thing. Just the same approach with the packaging, right? How you structure a project, right? If you know you're going to use an ORM to get off the ground quickly and you just do it because that's what everybody on the team knows, it's fine. If you need to then have specialized cases where you need to do raw SQL, you can do that too.
Right. Awesome. Cool. And I also, regarding still databases, is there any specific thing between Go and SQLite? I've been seeing a lot of projects that like use SQLite as well. And for this specific web app that I built, I used something called Lightstream. I'm not sure if you guys are familiar with it.
Yep.
Yeah, it backs up my SQLite database to an S3 bucket. That's
right.
It's really nice.
Yeah, you're not wrong.
Yeah, okay.
I mean, SQLite is and has always been sort of one of the favorite sort of developer tools out there, regardless of language, right? It's small, fast. You can go far, right, with a SQLite. Some people even ship with a SQLite database if they need to sort of package, sort of a database with their projects and whatnot. It's just a great all-around project. It's been around for years. It's just a great all-around project. The Go community sort of a liking SQLite. I think that's something that like predates Go. People just like SQLite and they just say, hey, I can, why not put both things that I really like, why not put them together and use them, right? So I think that's what you're seeing. That the love for both of those technologies together kind of makes it, like a pleasant workflow.
Yeah, it's kind of the go back to the simplicity of things. And in Lightstream was great experience for this project. No problems at all. I went with actually raw SQL instead of ORMs. And yeah, I didn't really like the migration experience because I need to write it myself, but I guess I'm the one to blame there. But awesome. Okay, great. Then I think I have a little bit more clarity here that you guys are not so extreme in the Golang side of things like I thought.
Yeah, we're a lot of things, but extreme is not doesn't tend to be one of the things that we ascribe to Go developers. Yeah.
Okay, awesome. And so one of the things that surprised me about Go when I was writing is that for this specific project, there needed something to happen. So where I needed to basically look at 5 different Danish newspapers, get their RSS feed, and then automatically throw them at a large language model to get the translation for the contents of those news, basically, and the translation for the title. So I basically wanted to do a bare bones, really simple website. I can just read Danish news from a bunch of different sources related to where I live, because I don't do Danish yet. Yeah, exactly. I'm very bad. And so one of the things that I need to do is that I actually need to request all of these RSS feeds, and I need to actively run all of these translations, so call all of these APIs, but I wanted to do it in a fast way. And when I think about Python, I was thinking, okay, if now I have to throw this thread pool executor, or I have to write a bunch of these boilerplate code to do some concurrency here, and I have to swim against whatever normal Python is to try to make this as efficient and concurrent as possible. And then I was like, should I actually do concurrency in Go? And there's this great website that I'm sure you guys know almost by heart, which is this Go by example website. And it showed me that all we need to do normally is like Go and then the name of the function, and it just runs it in the background. And I was like, what? Why don't we have a Go keyword in Python? This is great. And so I was really quickly in love with how I could actually call all these APIs and get these RSS feeds and call these translation services super fast and super concurrently without adding so much boilerplate to my code. It seems what it is, perfectly natural to Go, because I think that's one of the reasons why it was designed as well. And one of the questions I had is, I started noting that there's things like, I started doing things like channels. Then I said that there's also like weight groups. There's a bunch of perhaps different ways of doing concurrency. Is there a way that's like, for example, let's just put a simple thing. You need to call an API in parallel for 5 different, you want to call it at the same time. Do you jump for channels? Do you use weight groups? What do you go for?
Generally, the approach is, if you know how many Go routines you're going to need, if you need to manage the number of Go routines, and you know how many you're going to have for any given task, right? A weight group is usually a good starting point, right? So, and using your example, if you know you need to hit 5 different websites and say have 5 different workflows running, right? You call the website, you get some stuff, you parse the RSS, and you start feeding that into an LLM. Right, each one of those things could be a separate Go routine, right? A separate, basically, thread of execution, because these things that don't depend on each other. One website doesn't depend on the next, right? So you can simply, have those tasks happen in their own Go routines. In this case, you have 5 websites. You could, trigger 5 different Go routines. You just have to wait for them, right? Hence the name, wait group, right? So you initialize your wait group. You say, I'm going to add a count of 5, right? And then for each Go routine you launch, right, you're going to want to decrement, right, a counter. And there's a process for this, right? Calling a done function on a done method in your wait group, and went from inside of the Go routine you launch. And then every time a Go routine, returns, right, it decrements the counter automatically, right? So whenever you know exactly how many Go routines you're going to need to launch, a wait group is usually a great starting point. Channels are meant for communication between Go routines, right? So if you need, maybe in your main thread, your main Go routine, if you need some information, right, to be passed back and forth between your main Go routine and whatever other Go routines you've launched, channels are great for that, right? And they can channels have directionality, right? If you can have send only channels, bidirectional channels, right? And again, it's really used for communication purposes, right? And then there's other ways you can use channels, like almost like a queue kind of behavior, but that might be a bit more than we want to get into right now. But really, the channel is all about the communication, right? And then obviously, Go comes with things like mutex and whatnot for doing mutual exclusion, and that same notion exists in other programming languages, so I don't have to explain it here. But yeah, it's really, I think, for most people, I usually say, hey, can wait groups help you accomplish this task if you know how many things you need to do ahead of time, right? And I usually say start there.
But channels could do exactly that. Like what you said about weight groups, I could use channels to do exactly the same thing, or no?
No,
Okay.
not exactly the same thing, and not exactly in the same way. You'd be adding some overhead if you use channels. So, and for the example that we just walked through, you'd be adding some overhead to do it via channels. But it's doable. You just be adding a bit of overhead.
I would definitely mirror, like, kind of reach for channels last. I know it's like Go's flashy feature, but I'll often grab for a mutex way before I grab for channels. I think it's easy to reason about. And sure, there are good reasons to use channels, but almost always I'll avoid it if I can. I just also wanted to add, there's a sync x/sync/air group, which is very similar to a weight group. But basically, instead of directly launching Go routines, you give it a function that returns an error, right? And so then you can wait until everything's done, everything's returned nil, or you see the first error. And you can also, when you create this group, you can give it a context so that it cancels everything after the first error. And I find myself reaching for that way even more than weight group.
Yeah, that's a great package. Yeah.
Maybe my single favorite Go package.
So what's the name of the package? Wait a second.
Air group. ERRGROUP. Yep.
Gotcha.
It's in the experimental sync package.
Right. The last thing I'll mention before we move on to unpopular opinions, when you're doing concurrent work, and one thing I wanted to sort of bring to your awareness, Duart, when you mentioned it, Go is all about concurrency, right? You can enable your code to run in parallel, right? But concurrency and parallelism are not the same thing, right? You can have concurrency on a single CPU, right? For example, right? But, to enable parallelism, right? Having different things, multiple things happening at the same time, you're going to need multiple cores for that. And that's where the parallel comes in. Go allows you to write code that can be made parallel, but out of the box, it's all about concurrency, right? The other thing when it goes into concurrency is that you have to know which types, right, are thread safe, right? Maps, for example, are not thread safe, right? So, whether you sort of serialize access to those via a channel or whether you use a mutex, like Ian's saying, like you're going to want to protect that shared resource, right? Maps, same thing for slices, they're not thread safe, right? So, or counters and things of that nature. If you need to like sort of increment a count, and maybe you want to increment a count from within a Go routine, you don't want to use the regular basic integer types, for example. You're going to want to use an atomic version of that instead, right? Or again, use some sort of lock around whatever the resource you're trying to access. So that's the other thing I'll just throw in there. Just whenever you have concurrency or multi-threading in your programs, you want to protect shared resources.
I always forget about the atomic packages. I need to remember those more.
Yeah.
I think I need to refactor this project. I see, she's like, I know you shouldn't really add channels. That's just overhead. And I'm like, here looking channel equals make channel. For how many websites do you want to scrape?
Hey, we've all been there. Like, yeah, I think we all.
It works great, guys. Let me tell you, it hasn't gone down yet.
Trust me, like I did the same thing. I was one of those people who like, oh, channels everywhere. When I first came to Go, I was like, yo, this is amazing. And then you realize, oh man, I'm totally overdoing it and shooting myself.
Okay, so it was an honest question. Okay, so
yeah, you're good. You're good.
Yeah, you guys normally have one single way of doing things. That's why I thought.
We like to have those patterns, right? Those idioms. Yeah, indeed. All right, well, let's switch it up to unpopular opinions, shall we?
Probably leave.
Duart, I know you came with one in a holster. Lay it on us.
Yeah, I don't know if it's unpopular, but for me, the unpopular opinion is that there's no such thing as I don't have time for X, and whatever X is. And this, I think, is unpopular because I hear it from people all the time, and I also hear it sometimes from myself when I'm like, I want to do whatever, and I say, oh, but I don't have time to do X or do Y. For example, I run maybe like every day, like, I don't know, 80 kilometers or 70 kilometers sometimes a week, which is like 60 miles or something like that. And a lot of people like say like, oh, I don't have time for that, or I have kids, or I have other responsibilities. But I also always had the mentality that if you want to do something bad enough, you get time for it. And I know that a lot of people are going to be like, yeah, but you don't have my life, and look at all the things I have to do that you don't have to do. Sure. But I think that at a certain point, if you prioritize it enough you can actually do it and get time to it. You make time for it. You don't have it. You make it.
Yeah, I don't disagree. I think it's most of the time it's a matter of prioritization. And the other sort of nuance I'll add to that is if after you've done prioritization, right, which is sort of the first step, if after you've prioritized, you still don't have enough time to get to everything you want to get to, that's a signal that you have too many things on your plate and that you need to give up some things, right? You may have a desire to do all the things, but there's still 24 hours in the day. Ideally, you still just to sleep 8 of those, and you still have to go to work like most of us, 8+ hours a day, right? Whatever's left, right? If you don't have enough time to get to it, right? Even after you having done your prioritization, if you still can't get to everything, that just means you have too much on your plate. And I say that like, as sort of living proof, right? In my household of that particular problem. Like at the end of the day, I'm like, man, there's so much I'd like to get to. And, I go to bed sort of kicking myself, man, I couldn't get to this, man, I couldn't get to that. This is sort of, the universe telling me that, hey, you just simply have too many things on your plate. Because like I'm one of those people who tracks my time. Like my calendar literally has a block for I can tell you, 4 weeks ago what I was doing at this hour, right? Because it's on my calendar. I track my time to that degree, right? I know I'm a little bit anal about it, but I want to know that at the end of the day, I maximized my time, because time is the one thing I can't make more of, right? But at the end of the day, I'm going to bed and thinking, oh man, I couldn't get to this, I couldn't get to that. And if I do that enough times, I'm sort of defeating my own self. I'm beating myself up because I couldn't get to everything. That just means that I need to give up some things. I just don't have the cycles in my day for it. So
yeah, I mean, for me, that's a great answer. I think I'm a little bit OCD in the way I do things as well, John. So I could tell you what items I got done in 2.5 weeks from last year. Right, I could tell you. So, but yeah, I think that's the point that you said, is that it's a prioritization exercise, and you also need to be able to drop things, right? But if you don't have time, it's because you're not prioritizing the right things, but there's still a limit to the things that you can actually do. But don't you catch yourself sometimes saying like, I don't have time to do that?
Of course. It's a natural human, thing to do. I think it's a natural. Yeah. I'm like, man, I don't have time to do anything.
Exactly.
When I find myself thinking that, I try to change it to, I'm not motivated to do X.
Exactly.
That's interesting. Yeah.
Exactly.
Good stuff. Well, I don't have an unpop. Ian, I'm not sure if you do.
Maybe I go back to the channels versus mutexes. I think in almost every case, mutex is probably the right tool for the job. Not every case. I don't know. Maybe skip this. I don't. 90% of the
You're
time.
going back on it. You're going back on it. Okay. Well, maybe this will be my unpop. I think you should be very careful with your use of mutex, especially if you have a sort of a high throughput sort of situation, because mutex will have a tendency to slow things down, because once you lock a particular resource, everything is paused. Nothing else can access other than the go routine for which you open up the lock, right? So if you have sort of a high throughput situation, whatever amount of time a particular go routine spends, updating a particular shared value, nothing else can work, right? So there may be more efficient ways of doing what you're trying to do without a mutex. Again, in some simple cases, mutex is a go-to, but you have to definitely consider the cost of using the mutex, right? Because nothing else, everything in the world stops, right, until the go routine is done for that particular shared resource.
I'm just trying to rack my brain for one of those high throughput situation where even a read write mutex wouldn't solve a lot of that. I don't know.
Right. Yeah. Again, it's one of those things where you have to look at your use case and sort of make the appropriate decision.
Okay, so it's even weight groups, channels, and you tend not to go with channels, tend to go with mutexes.
I mean, when channels are the right thing, I'll use a channel, but I just don't think that's very often.
Okay, wait, can you just put some words into what? Because I'm realizing now that in Go you have 5 different ways of doing concurrency. I thought we had a simple way of doing everything, but what is can you tell me
I mean, I think Johnny said it really well earlier when it's about communicating.
Okay. Exchanging data between some of these processes. Okay, gotcha.
I don't know. It's also one of those things where you just know it when you see it. Like, I don't know. I can't put words to
Well,
it.
I mean, you can't like a new. You're gonna tell a new gopher, right? You'll just know when you see it.
I haven't converted yet, but sure.
Right. Yeah, it's just all you have to do, Duarte, is to spend the next couple of years, hacking away at Go, and then you'll know it when you see it. Says
sure.
Ian.
Okay, thanks, Ian.
I know it's not helpful.
I got so much guidance. I'm kidding.
Awesome. This was great. Thanks, Duarte, for coming on the show and definitely for suggesting the episode. Dear listener, if you too want to come on Go Time and talk Go, whether you have a bone to pick with the language and you want some ears to hear you, or you have some questions along the lines of Duarte's set of questions today, definitely reach out to us and we'd love to have you.
Thanks for having me, guys.
All right, let's wrap this up.
All right, that's our show. Thanks for hanging with us. Subscribe now if you haven't yet. Head to gotime.fm for all the ways. Or search for GoTime wherever you get your podcasts. You'll find us. If you're a fan of GoTime and get value from the pod, share the show with your friends and colleagues. And if you really dig it, hook us up with a 5-star review. We appreciate it. Thanks once again to our partners at Fly.io, to our Beat Freakin' residents, Breakmaster Cylinder, and to our friends at Sentry. Save $100 off their team plan when you use code CHANGELOG during sign up. That's all for now, but we'll talk to you again next time on Go Time.